Here's another video on the derivative of trigonometric functions, and this time I'll be discussing higher order derivatives for some trigonometric functions. And allow me to start with the higher order derivatives for y equals sine x. And you know that the first derivative of y equals sine x is cosine of x, and differentiating dy dx, that will give you the second derivative of y in terms of x, and that is equal to the derivative of cosine x, which is negative sine x. And the third derivative is equal to the derivative of negative sine x, and that will give you negative cosine of x. And then differentiating this, you'll have the fourth derivative of y in terms of x, and that is equal to sine x. And you will now observe that the fourth derivative of y is equal to the original function y equals sine x. So which means the fourth derivative of y in terms of x is equal to sine x, and the fifth derivative of y in terms of x is equal to the first derivative, and that is cosine of x, and that the sixth derivative of y in terms of x is equal to the second derivative of y in terms of x, and that the seventh derivative of y in terms of x is equal to the third derivative of sine x, which is equal to negative cosine of x. And as we continue on the sequence of higher order derivatives, you will observe that the eighth derivative of y in terms of x is the same as the fourth derivative, and that the ninth derivative is equal to the fifth derivative, the 10th derivative of y in terms of x is equal to the sixth derivative, and that the 11th derivative of y in terms of x is also equal to the seventh derivative, and going on. Okay, so the 12th, the 13th, the 14th, the 15th derivatives are equal to the 8th, the ninth, the 10th, and the 11th derivatives respectively. Okay, and as we continue, we know that the kth derivative of y in terms of x is equal to y equals sine x if when k is divided by 4, the remainder is 0. So that's if k modulo 4 equals 0. And that the kth derivative of y in terms of x is equal to the first derivative, okay, of y in terms of x, which is equal to cosine of x, if k modulo 4 equals 1. That is when k is divided by 4, the remainder is 1. And then, if k modulo 4 equals 2, the kth derivative of y in terms of x is equal to the second derivative of y in terms of x, and that is equal to negative sine x. Okay? And finally, if k modulo 4, k is equal to 3, that is when k is divided by 4, the remainder is 3, then the kth derivative of y in terms of x is equal to the third derivative, which is equal to negative cosine of x. Okay? For instance, if we want to get the 97th derivative of y in terms of x, if y equals sine x, so we just simply divide 97 by 4, and the result is 24 remainder 1. So which means 97 modulo 4 equals 1. So which means this is your 97th derivative of y in terms of x. And finally, the 97th derivative of y in terms of x is just equal to cosine of x. Okay, let's have another one. Say we want to get the 111th derivative of y equals sine x. Okay, so again, dividing 111 by 4, you will observe that 111 modulo 4 is equal to 3, or that's 27 remainder 3. Okay, and then we can now see that uh, the 111th derivative of y in terms of x is also equal to the third derivative of y in terms of x, since when 111 is divided by 4, the remainder is equal to 3. Okay? So we have the 111th y of 111th derivative of y in terms of x is equal to negative cosine of x. Okay, so to make it more generalized, we have here y equals c sine ax, and then differentiating. So we just copy c, and you know that the derivative of sine ax is cosine ax, then differentiating ax is equal to a. So that's c a cosine ax. And again, differentiating this, so you will copy ca, okay? So copying CA and then differentiating cosine, that will give you negative sine AX. Okay. And then differentiating AX will give you another A here. Okay. And that will makes A squared. Okay. Therefore, the second derivative of y in terms of x is negative C A squared sine AX. Getting the third derivative, so you just copy negative C A squared, and you know that the derivative of sine AX is a cosine ax, and then you just multiply this a to a squared, so that will give you a cube. Okay, so you will have negative c a cube times cosine ax, and you will observe that the fourth derivative will have a structure like this. Okay, and then this will be the fifth derivative, the sixth, and the seventh. So we shall have the kth derivative of y in terms of x is equal to c times a raised to k sine ax. Okay, and that happens whenever k modulo 4 is equal to 0. And then the kth derivative of y in terms of x is equal to c times a raised to k cosine ax if k modulo 4 equals 1. And the kth derivative of y in terms of x is negative c times a raised to k sine ax if k modulo 4 is 2. And finally, the kth derivative of y in terms of x is negative c a raised to k cosine ax if k modulo 4 equals 3. So we shall have, okay, the 83rd, we are looking for the 83rd derivative of y in terms of x if y equals 1 half sine 3x. So here, c is equal to 1 half and a is equal to 3. And then dividing 83 by 4, we shall have 20, remainder 3. So which means 83 modulo 4 equals 3, which means the 83rd derivative of y in terms of x will have a structure like this. Okay, that's negative c. So that's negative c, negative 1 half, a, that's 3, and then raised to k, that's 83rd, and then you copy cosine, cosine ax. So that's cosine 3x. So we shall have the 83rd derivative of y in terms of x is negative 1 half times 3 raised to 83 cosine of 3x. Let's have some more. The 50th derivative of y in terms of x if y is equal to negative 2 sine 2 third x. You know that c is negative 2 and that a equals 2 third. Yeah. And then dividing 50 by 4, we shall have 12 remainder 2, or 50 modulo 4 is equal to 2. So this is the 50th derivative of y in terms of x. So we'll have a structure like negative c a raised to k sine ax. So we shall have 2, okay, that's negative from the formula, okay? And then since this is negative 2, so that's negative 2, and then you copy 2/3, okay? And then raise it to the 50th power, and then you affix sine ax. Sine 2/3 of x. So you shall have negative times negative 2 is positive 2, then copy 2/3 raised to the 50th power, then copy sine 2/3 of x, okay? And then for the higher order derivatives of y equals c cosine ax, let us first generate the first three derivatives. And this is negative c times a times sine ax. That's the first derivative. The second derivative is negative c a squared cosine ax. Okay. And then the third derivative is c times a cubed times sine ax. And then we shall have the kth derivative of y in terms of x will have a structure like this. Okay. We just only multiply it by a raised to k since the derivative of ax is a. So we shall have c times a raised to k cosine ax, and this happens whenever your k, okay, modulo 4 is equal to 0. Okay, and then the kth derivative of y in terms of x is equal to negative c times a raised to k sine ax if k modulo 4 is equal to 1, and the kth derivative of y in terms of x is equal to negative c times a raised to k cosine AX if k modulo 4 is 2, and the kth derivative of y in terms of x is equal to c times a raised to k times sine AX if k modulo 4 is equal to 3. Okay? So these are our patterns if we want to get the 120th derivative of y in terms of x if y equals negative 3 cosine of 5x. So you observe here that c is equal to negative 3 and that a is equal to 5. Okay, dividing 120 by 4, that's 30 remainder 0. That means 120 modulo 4 is equal to 0. So which means we shall have the 120th derivative of y in terms of x, that's c, okay, where c is negative 3, so negative 3, then a raised to k, that's 5 raised to 120, and then you affix cosine ax, and that's cosine 5x. Okay, one more. Say we want to look for the 50th derivative of y in terms of x if y equals to cosine half x. Again, we know that a is equal to 1 half and that c is equal to 2. And then dividing 50 by 4, okay, that's 12 remainder 2, or 50 modulo 4 equals 2. So this is the 50th derivative of y in terms of x. So it will have a structure like this. So that's negative c, okay, that's negative 2 times 8 raised to k, that's 1 half raised to 50. Then you just affix cosine of ax, and that's cosine of 1 half x. And then you can still simplify this part, okay? Negative 2 times 1 half raised to 50, so that's negative 2. You know that 1 raised to 50 is 1 all over 2 raised to 50. 2 raised to 50. And then negative 2 over 2 raised to 50 is equal to negative 1 all over 2 raised to 49 cosine of 1 half of x. Okay, so next example. We wish to find the second derivative of y in terms of x if y equals 2 tangent half x minus x. Okay, to get the second derivative, we first get the first derivative of y in terms of x, and that is equal to the derivative of 2 tangent half x minus derivative of x. And then differentiating, you know that the derivative of 2 tangent half x, that's 2 times derivative of 1 half x is 1 half, okay? And then the derivative of tangent is secant squared, and then you just copy the parameter half x. Okay, and then you know that the derivative of x is equal to 1, so you have negative 1 on the second term. Then multiplying 2 and 1 half, you will have 2 times 1 half is 1, then you will only have secant squared half x minus 1. And then you recall the identity, tangent squared x equals secant squared x minus 1. Therefore, this secant squared half x minus 1 is just equal to tangent squared half x. So we have dy dx equals tangent squared half x. And then differentiating this, we will obtain our second derivative of y in terms of x. And then applying the techniques in differentiating powers of tangent, okay? So you just get the derivative of 1 half x, and that's 1 half, okay? You multiply it to the power 2, okay? And then you copy tangent, half x, and then you subtract 1 from 2, and that is equal to 1. And then you just simply affix secant squared with the same parameter half x. And therefore, dy dx is equal to 1 half times 2. This is equal to 1. Tangent half x times secant squared half x. Okay? And one more. Say we wish to find the second derivative of y in terms of x if y equals cosine cubed 2x at x equals pi over 12. So we will be looking for the definite derivative of y equals cosine cubed 2x at x equals pi over 12. Okay, differentiating, we will be applying the special formula for the powers of cosine again. you just differentiate 2x, that's 2, and then you multiply it to the power 3, okay? And then you copy cosine 2x, copy cosine 2x. You subtract 1 from 3, so that will become 2, and then you just simply affix negative sine 2x because the derivative of cosine is negative sine. So simplifying this, negative 2 times 3, that's negative 6, and then you just copy cosine squared 2x times sine 2x, and that is the first derivative of y in terms of x. Now, to get the second derivative, you might use the derivative of product, but if you want to avoid the use of derivative of product, we just simply simplify this, okay? So we shall recall that the cosine squared x is equal to 1 minus sine squared x. Therefore, that cosine squared 2x is just simply equal to 1 minus sine squared 2x. So we shall have dy dx is negative 6, and then we just simply replace cosine squared 2x by 1 minus sine squared 2x, then times 2x. And then the next thing to do is you introduce this sine 2x, each term inside, along with this negative 6. So dy dx is negative 6 times 1 times sine 2x is negative 6 sine 2x. Then negative 6 times negative sine squared 2x times sine 2x is positive 6 sine cube 2x. Okay, so here we can now avoid the use of product for derivative of product. So differentiating the second derivative of y, okay, so you know that the derivative of sine 2x is 2 cosine 2x, and then you just multiply it to negative 6 times negative 6. Okay, and then for 6 sine cube 2x, you just applied the techniques on differentiating the power of sine, and that is equal to derivative of 2x, that's 2 times, then you multiply it to the power 3, okay? And then you copy sine 2x, and then you subtract 1 from 3, and that is equal to 2, and then you just simply affix cosine 2x, and do not forget to multiply it by 6 times 6. So this is negative 12 cosine of 2x plus how many? That is 6 times 2, 12 times 3, that's 36 sine squared 2x cosine of 2x. And here it goes. Okay? And then to get the definite derivative at x equals pi over 12, so you just simply replace x by pi over 12. And it will look like this. That's negative 12 cosine of 2 times pi over 12 plus 36 sine squared 2 times pi over 12 times cosine of 2 pi over 12. And you know that 2 times pi over 12 is pi over 6. This is also pi over 6. This is also pi over 6. So we shall have, okay, so the second derivative of y in terms of x at pi over 12 is negative 12 cosine of pi over 6, 36 sine squared pi over 6 times cosine pi over 6. And to evaluate the value of cosine pi over 6 and sine pi over 6, we can use this triangle, okay? And then by applying the Pythagorean principle or the SOHCAHTOA principle, if this is your pi over 6, and then the adjacent side is equal to square root of 3, and then the opposite side is 1, and that the hypotenuse is equal to 2. Okay, so which means cosine of pi over 6 is equal to SOHCA, that's adjacent side, square root of 3 over 2, and that sine pi over 6 is equal to opposite side, 1 over hypotenuse. That's 1/2. Okay? So substituting these values to the equation, you shall have negative 12 times square root of 3 over 2 plus 36 times 1/2 square times square root of 3 over 2. Simplifying, you know that this 1/2 squared is equal to 1/4, okay? And then you know that 12 over 2 is equal to 6. So we shall have negative 12 square root of 3 over 2. Then this is 36 times 1/4 is 9 over 2 square root of 3. Okay? And then adding these two fractions, So this, the second derivative of y in terms of x at x equals pi over 12 is simply equal to negative 3 square root of 3 all over 2. Okay, let's see if we have, okay, so we wish to find the second derivative of y in terms of x if y equals x squared sine x plus 2x cosine x minus 2 sine x. So for the first term, we use derivative of product. So the derivative of x squared sine x is, that's x squared. I'll write it here. And then times derivative of sine x, it's cosine of x. And then plus sine x times derivative of x squared, and that is 2x. And then for the second term, 2x cosine x, its derivative is 2x times derivative of cosine x, that's negative sine x, plus cosine of x times derivative of 2x, which is simply equal to 2. Okay? And for the third term, that's negative 2 sine x, the derivative is simply negative 2 cosine of x. And then, simplifying these three terms, you'll have x squared cosine of x, then plus 2x sine x. Okay, here it goes. And then minus 2x sine x. Okay, and then plus 2 cosine of x, then minus 2 cosine of x. And then you can observe that this 2 cosine x minus 2 cosine x will become 0 along with this 2x sine x and negative 2x sine x. So we shall now only have x squared cosine of x. And then to find the second derivative again, we use the derivative of product. So this will be our u and this will be our v. And then doing the same, so we shall have x squared times derivative of cosine x is negative sine x, then plus, you copy cosine x, okay, and then you differentiate x squared, and that is 2x, okay? So therefore, the second derivative of y in terms of x is equal to negative x squared sine x plus 2x cosine of x. Okay, we wish to find the second derivative of y in terms of x if y equals to sine x sine 2x. Again, this is written as product, okay? Product of sine x and sine 2x. So given that form, then we can use the derivative of product, u v. Okay, so that's u dv plus v du. Now, if you want to avoid the use of derivative of product, then you can just simplify this sine x sine 2x by applying the product to some identity. You recall that sine x sine y is 1/2 cosine x minus y minus 1/2 cosine x plus y. So x is represented by x and y is represented by 2x. So we can now rewrite this sine x sine 2x as, and then you just copy 2 in front, then 1/2 cosine x minus 2x minus 1/2 cosine, then x plus 2x. And then you can just introduce to each term inside, and by applying the odd even identity, you know that cosine of negative x is positive cosine of x. And this cosine of x minus 2x is equal to cosine of negative x. So we shall have, okay, 2 times 1/2 is 1. Then cosine x minus 2x is negative x. Then by applying the odd even identity, that will become cosine of x. And then you know that x plus 2x is 3x. Okay. And then 2 times 1/2 is 1. So we shall only have y equals cosine x minus cosine 3x. And then we can now differentiate y. Okay, the derivative of cosine x is negative sine x, and that the derivative of negative cosine 3x is positive 3 sine 3x. Getting the second derivative, the derivative of negative sine x is negative cosine x, and then you just copy 3, differentiate sine 3x, and that will give you cosine 3x, and then you differentiate 3x, which is 3. So 3 times 3, it's 9, and then cosine 3x. And that is the second derivative of y in terms of x. Let's see if we have some more. Okay, that's the end